Okay guys, I'm back with another segment of the problem session number 5 problems. I've got a really nice problem here to show you that I like this problem a lot, and there will be many other problems like this one that could be created. So you definitely want to understand how this works. Okay, we have sort of a usual assumption here. F is continuous on a closed interval, differentiable on an open, on the same interval but at open. And then it says, prove that there exists a C in the open interval such that f prime of C is equal to something. Kind of reminds you of something, doesn't it? It should remind you of the mean value theorem. All of the assumptions are the same. We're talking about the existence of a point where the derivative of the function is equal to something. In the mean value theorem, of course, on the right-hand side, what we have is f of b minus f of a over b minus a. So this time the right-hand side is more complicated. But we still probably have a notion that the mean value theorem could be used here. And in fact, that is right. And the trick to this, and this is where you might want to pause the video after I give you the little trick and think about it, and then you can watch what actually is the right thing to do. The trick to this is to apply the mean value theorem, but not to the function f. Can you, based on what you see on the right-hand side, apply the mean value theorem to a different function, let's call it g? Okay, so if you want to pause the video for a second to think about what that g of x function would be, this would be a good time to do that, and then I'm going to tell you the answer as soon as we keep rolling here. Okay? All right, so based on the form of what you're seeing kind of on top here especially, right, you might have suspected that you would want to let g of x be equal to x squared times f of x. This is the trick, okay? Because then what you have here is g of b minus g of a, right? Okay, so, and of course this function is equally continuous and differentiable, so we can still apply the mean value theorem to it. So apply the mean value theorem to g. Okay, so what we would get then is that there exists a C in the open interval AB such that g prime of C is equal to, well, it's just g of b minus g of a all over b minus a, which of course is just b squared f of b minus a squared f of a all over b minus a. Okay? So that's just the mean value theorem applied to g. However, on the left side we have the derivative of g. I can actually calculate what that is in terms of f, because of course this boxed expression doesn't have g in it anywhere, so we need to get everything in terms of f. So if I take the derivative of g, what I'm going to get here for the derivative of g is, well, by the product rule, x squared times f prime of x plus 2x times f of x. Okay? And so what we can do is we can take that and put that, plug in c into that, and so in other words, this is going to equal c squared f prime of c plus 2c f of c. Okay, so basically we're focusing on this here now, right? These two things are equal. Well, if you solve that for f prime of c, you're going to get exactly this. Okay? It's actually pretty simple. That's all there is to the problem. The hardest part really is just realizing that you need to create a new function, g, that you can then apply the regular mean value theorem to. Okay? So that's it. Okay? Just coming up with the formula for g is really the secret to it. So now you just do the algebra here and you're going to get that boxed equation. I'll let you guys check that part, that the algebra actually works. But that's the solution. Okay? And, you know, if you want to make up examples to give to your friends to practice that kind of problem, you can do it. You can just say, gee, I'm going to think what I want my g of x function to be. Maybe you choose this, right? And then you can take the derivative of it, and basically run the mean value theorem through it until you get an expression, and then you just hand the expression, like that box formula, you just hand that to your friends and say, all right, solve this problem, and then they have to think up this as the function to use. So it's actually easy to create questions that are kind of like that. You're applying the mean value theorem to, not to f, but to a slightly different version of f, to a tweaked version, if you will. Okay, let's look at the next problem, number 4. On this one, we're taking f of x to be the arctangent of x, okay? And there's a couple of parts here to this question. The first part is just asking you to find the derivative, or show that the derivative of f is 1 over 1 plus x squared. So this is probably a familiar formula from calculus for you, and we would like to show that, okay? And we're supposed to show it by using the rules of differentiation. Okay. The important thing here is to understand that this arctangent function is an inverse to the tangent function. So in other words, if I create a function g of x, which is just the tangent function, well, then what we know is that f of g composed, if I compose f with g of x, I just get x, and actually it works in both directions here. Okay, so in both directions, when I compose the tangent function with the arctangent function, you end up getting the identity function, right? So the functions become the identity function. Okay, we're looking for f prime of x. Now, of course, once you write this down, you likely are thinking about the chain rule for derivatives, right? So you have a couple of choices of how you play. You can use this one or you can use this one. If I use the one on the top, then what I'm going to get for the chain rule, I'm just going to write down again what the chain rule tells you. Okay, you're going to take the derivative of the left side, and that's going to equal the derivative of the right side. Okay. On the other hand, if you do the same thing to the bottom one, well, now what you're going to have is g prime of f of x times f prime of x. And the question is, would you rather work with this one or would you rather work with this one? Well, you have to look at what you're trying to show, right? You're trying to come up with a formula for f prime of x. Well, I explicitly have f prime of x right here. Okay, so it makes sense that we might use this one. Okay, g of x, of course, we can differentiate this one just using the quotient rule, right? A tangent of x is just sine over cosine. We can use the quotient rule, and what we will find right away is that this is just secant squared of x. Okay, so then when I plug that into here, of course, I'm just going to have secant squared of f of x, right? And then that's times f prime of x equals 1. Okay, so I'm going to erase just right here really quickly so I have enough room to finish this. But see, I can solve now for f prime of x. F prime of x would equal 1 over secant squared of f of x. Well, that would be secant squared of the arctangent of x. Okay, this is actually where you need a little trick. You probably never thought you'd use that in this class, but we actually are going to use a little triangle here to help us understand how this comes about. Okay, so we have some angle here, theta. This is a right triangle. Kind of remember your trigonometry. Let me just move this over just a little bit. Just put it right here for you. Okay, so imagine you have that, and here's the angle that you're looking at. So if I call the arctangent of x, if I call that theta, this just means the tangent of theta is equal to x. Tangent of theta is just opposite over adjacent when you're thinking about the trigonometry of this right triangle. Okay, and then if I've set that up, then of course my hypotenuse by the Pythagorean theorem is the square root of 1 plus x squared. Okay, so then what you're looking at here is the secant squared of theta. And secant squared of theta is really, well, so the cosine is adjacent over hypotenuse, and the secant is the reciprocal of that, so it would be the hypotenuse over the adjacent. So it's really this over this, which is the square root of 1 plus x squared, and then you're squaring that. So you just get 1 plus x squared on the bottom. It's just coming from this triangle, okay? So it's a little bit of trig and geometry here, amazingly enough, in this problem. But that is an excellent way to prove that the derivative of f of x is 1 plus x squared. Okay? All right, I've got a couple more problems. I'm going to, again, stop the video briefly, and then I'll start it up with the final segment. All right, thanks, guys.